Let's talk about the progression of a satellite around the planet Earth. And we're given a few things here to start with. I know that the satellite's orbit is 4,208 miles from the center of the planet, and that it's traveling at a velocity of 16,056 miles per hour relative to the surface of the Earth. Now, the reason that's important is because the Earth is rotating too, but because this is a speed relative to the surface of the Earth, we don't need to worry about the Earth's rotation. That's already taken care of for us. So the question is, how far, measured in sort of a degree system around the circle of the Earth, how far has the satellite traveled in a certain amount of time, which is 17 minutes? So what I'm going to do is set up what I want on this side. I have my degrees per minute. That'll tell me how many degrees each minute this satellite is going. And on the other side, I've set up the best I can do, the speed in miles per hour of this satellite. Okay, that's this v right here, the linear velocity perpendicular to the height above the Earth. So let's put in some fractions to try to help us. First of all, I want hours out of there. I really don't want this thing expressed in hours. I want it in minutes. So how do we do that? Well, we put hours on the top of this fraction over here, and we put something else on the bottom. I think minutes is going to be more useful. Now, how many hours are there in minutes? Well, there's 1 hour, and there's 60 minutes. So you can see what that's going to do for us. That's going to be really nice, and I get to cross out the hours then, and I'll have my velocity in terms of miles per minute. Well, that's good progress. But I still need this in terms of degrees, not miles. So the next fraction I'm going to do is something to cross out the miles. I want miles gone, and I want degrees in its place. Now, how many degrees around a circle are we? And what I'm talking about is this black circle right here, this outer edge where the satellite lives. How many degrees around is that? Well, it's any circle. It's 360 degrees. How many miles around is it? That's a different question. That's the circumference of a circle. That's 2 pi times 4,200 and, oh, not 80, 4,208 miles. Okay, that's how many miles around the circle is. So there we go. I've got my equation. Look what cancels out now. It's going to be miles canceling out with miles over here, and all that's left is degrees on top and minutes on bottom, and that'll be our answer for the first part. Now, when you actually go and plug that into the calculator, let's see what we get. And you want to be careful to include lots of decimals on this problem. You get 3.64362 and some more things after that, degrees per minute. Now, here's the part where, don't lose track of what we're doing. We're saying how far does it go in terms of degrees in 17 minutes. So you take this degrees per minute and you multiply this answer right here by 17 minutes. Okay, and that's going to give me the total number of degrees traveled, which is, let's see, my calculator says 61.9415 degrees. Okay, that means this satellite, which might have started off over here, takes a pretty good trip, carving out a nice section of the planet there, maybe 60, 61, 62 degrees in only 17 minutes. Got a good chunk of the way around. Now, the next part of the question, right? Okay, so this goes up here, 61.9415 degrees. The next part of the question focuses on whether you remember that there's an alternate way to measure angles. I'm not talking about radians. I'm talking about more of the cartographer type stuff with maps and longitude. Degrees, minutes, seconds. Okay. Well, the degrees is very easy. That's simply the 61 that we found. The next part, if you scribble out the degrees, you ask yourself, okay, 0.9415. Well, how many minutes is that? And what you have to do is this. You say, I'm going to take my minutes, and that's equal to 0.9415, the leftover bit of degrees, the decimal part, times 60. Okay, so let's see what we get there. 0.941 blah, 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 times 60, okay, equals 56.4918 minutes. Okay, so there's my 56. And then when I have to do the next part, which is my seconds, I take the 0.4918 portion and I multiply it by 60 again. Okay, so that's 0.4918 times 60. I'll bet it's close to 30. Yeah. Okay, so we have 29 0.51 seconds. And I'm just